Hi, I'm Coach Cowland, and in this presentation we're going to look at impulse and changes in linear momentum. So Newton's first law says that an object will stay in motion unless an external force acts on it. Well, if an object is in motion, it has momentum because it has a velocity, and if there's a change in that, then that means that a force must have been involved. And uh, so that means that the change in momentum is related to the force that acts on it. Impulse is related to that change. So the definition of impulse is the change in momentum of an object, and it's given by the variable j. And j is just equal to the change in momentum p. So to find the change, you find the difference, which is the final momentum minus the initial momentum. In this equation here, j is equal to mvf, which is final velocity, minus mvi, which is the initial velocity. The units of impulse are the same as the units of momentum, which is kilograms meters per second. So the impulse momentum theorem states that the force that causes the change is inversely proportional to the time taken for the change in momentum to occur. And that means that if the time is very small, the force is going to be very large. It also means obviously, if the difference in velocity is very big, then the force will also be very big. So, how does impulse relate to forces? Well, the force is equal to J, the impulse, divided by the time taken for that to happen. So, if I expand J, if I expand the impulse, I get mvf minus mvi divided by t, which is the time, gives me the force in newtons. So let's look at an example. A basketball of mass 0.6 kilograms hits a backboard at 4 meters per second and rebounds at the same speed in 0.05 seconds. If it rebounds, it's going in the opposite direction, so it's going at negative 4 meters per second as velocity. So the question is, what is the force on the ball? Well, there's the ball going backwards and forwards, and if we plug this into the equation, mvf is negative 4 times 0.6 and vi is 4 times 6, and if you're subtracting that and the time taken for that is 0.05 seconds, the force on the ball is negative 96 newtons. Newton's third law says for every action there's an equal and opposite reaction, so the force that the ball applies to the backboard is positive 96 newtons. So implications of this. When there's a change in momentum, there are forces involved. If you go from very fast to very slow all of a sudden, then there has to be a force involved somewhere for that to happen. The more sudden that change, the greater the force is. So if you change speed abruptly from 30 meters a second to 0 meters a second in a very small amount of time, then the forces are going to be very high. If you change from 30 meters a second to 0 meters a second over a long period of time, the forces are going to be small. When you have a change in direction, because the velocity has a different sign, the impulse and hence the forces involved are going to be very big, because when you're finding the difference, you're actually subtracting a negative, and that means you're adding. So you end up with very big forces when there is a direction change, like when a ball hits something and bounces back off of it. Okay, that's it. Thanks for watching.